Let's do some mole conversions. So here they're showing us this mole roadmap. And it basically shows us that the mole is this unit. And we can use that unit to convert between moles and numbers of particles. That could be atoms or molecules. We could have moles and convert to mass in grams. Or eventually, when we're looking at gases, we usually quantify an amount of gas by its volume. So eventually you can even convert from moles to volume of gas. We're going to start by focusing mostly on the particles and the mass. And so they give us this roadmap, and it kind of shows you like mathematically how to convert between moles and particles or moles and mass. But to be honest with you, I don't think you need it. I don't think you need a fancy roadmap. You just need this concept of a proportion. We need to know how to set up a proportion and cancel units properly. So for example, here they're giving us 3.2 moles of nitrogen dioxide, and I want to know the mass. And so yeah, there's all these steps involved, but here in a nutshell is what I think in my head. I think start with not only the number that I've been given, 3.2, but also the unit. That's crucial. 3.2 what? Oh, it's 3.2 moles of NO2, nitrogen dioxide. And then I know I'm going to set up a proportion. Okay, so the unit that I have, I want to get rid of. I don't want my final answer in moles anymore. So you put moles on the bottom of your proportion. The unit that you want goes on top. So when they say what is the mass in grams, we're going to put grams on the top. Now I always set up my proportion. I put my units in first, and then I can find the numbers. Anytime you see grams on the proportion of a mole conversion, grams is going to come off your periodic table. Now, if it's an element, I can just look up the mass. If it's a compound, I need to add the mass. So before I can plug in grams, I need to add nitrogen. Its molar mass is about 14.01. In this compound, there would be 1 nitrogen, or on a larger scale, 1 mole of nitrogen atoms. Oxygen is about 16 grams per mole, but there would be 2. So I plug this in my calculator. I need to add it up. Not a hard calculation, right? 14.01 plus 2 times the oxygen gives me, what do you know, 46.01. Now that's grams per mole for the entire compound, NO2. That's then what I'm going to put in my proportion by grams, 46.01. And then that is the molar mass. When I use the masses on the periodic table in grams, molar mass is just defined as the mass of 1 mole. How easy is that? And so here, they've got 1, 2, 3, 4, all these steps in there. This is what I'm thinking in my head. I set up my proportion, and yeah, in the end, it looks like what they have here, right? I'll make those eyes like happier eyes. Whoa, there's happy eyes. But I don't always think about all those individual steps. I think about the proportion. I think about putting my units in correctly to cancel what I have, and then what I want goes on top. Now when I plug this in my calculator, I see that I've got moles on the top, moles on the bottom. Those will cancel. I'm going to multiply any numbers across the top and divide by anything on the bottom. So I just take my 3.2 times 46.01, and you can divide by 1 if you want to. But then, sure enough, I'm looking at about 147.2, and then that would be grams of NO2. I get the same answer. How cool is that? And again, on my molar masses off the periodic table, I usually go about 2 decimal spots. Here it looks like they rounded to 1 decimal spot. I like 2, it just leaves a little more precision maybe. But yeah, I got the same answer. I just didn't do quite as much work. Awesome. So same thing with this example. We have aluminum. It's used in aircraft parts and cookware. It's resistant to corrosion, which is pretty fantastic. What is the mass in grams of 9.45 moles of aluminum oxide? All right, so we start with the amount that we've been given. So if I were setting this up in my head, I'm looking for some kind of a number. Oh, I see it, 9.45, and I want the units. What is this? It's moles of aluminum oxide. Now, blast from the past, we may run into some ionic compounds. Now, eventually here they tell me the formula, but what if they didn't? I may need to write ionic formulas again. And so on my periodic table, I've still got the charges written in, that aluminum is a +3, oxygen is a -2. I gotta make it neutral. So you could either multiply that 3 times 2 and the 2 times 3, or you can crisscross the charges. But I do need to go back to writing some of these formulas. Now again, they told me, so this one I was in the clear, but that won't always be the case. All right, so I know I'm setting up a proportion. The unit that I have is going on the bottom. I don't want this in moles anymore. The question says, what is the mass in grams? I want grams on the top. Whenever I see grams, I'm going to the periodic table. Now again, when it's a compound, I just have to add it up. If it was an element, then that mass on the periodic table is the molar mass. It is the mass of a mole. Here I just got to do a little sidebar and add them up. Aluminum is about 26.98 grams per 1 mole. I'm going to have 2 in my compound. Oxygen is about 16 grams per mole. There are 3. I'm going to add all of those up, and that will be my molar mass of the compound. Not a tricky calculation. Oh, let's see here. 26.98 times 2 plus 3 times 16. Yeah, so I get about the same answer that they do, and with a little more precision, which just means like a few more decimal spots. I'm getting 101.96, and the definition of molar mass is the mass of a mole. And so again, they kind of did the same thing. They just set it up a little bit differently. And so whatever works for you, but it's really not meant to be a crazy calculation. I just need to find the masses of the elements and multiply by the number of atoms in the compound. Awesome. So now I've got this set up. I've got moles on the top, moles on the bottom. They'll cancel. And I just multiply across. And so, yeah, I mean, eventually it looks like what they got. I'm doing the same thing. I'm going to multiply 9.45 times my 101.96, or they used 102. And so we're a little bit less than 1,000. 964 grams of aluminum oxide. Now, it's always good to just kind of check your final answer and see if it's reasonable. So we've got 9.45 moles. Each mole is about 102 grams. So if that would have been 10 moles of aluminum oxide, and let's say each mole is about 100 grams, well, yeah, 10 times 100, I'd be looking at about 1,000. So I've got a little bit less than 10 moles. So yeah, that number seems reasonable. Should be a little bit less than 1,000 grams. Same thing with this guy. This NO2, I've got 3.2 moles. Each mole is 46-ish grams. I mean, you can kind of estimate, about 3 times 46. Yeah, I mean, it's like a little bit less than 50. So I'm looking for maybe like somewhere around 150, a little bit less than 150. It seems reasonable. So let's try one. Calculate the mass in grams of 2.50 moles of iron 3 hydroxide. Notice that they didn't give me the formula. That's fine, I can write formulas. This is iron, Fe. The charge is going to be +2. The Roman numeral is telling me the charge on the transition metal. Now we marked it in our books. It's earlier. Oh gosh, it's like, let's see if I can find it here. It's in the ionic section. There's that polyatomic ion chart. And it might help to kind of keep that bookmarked. Oh, let's see, where's that little booger? Ionics. Oh, I'm close. I'm really close in my book. It's page 98. That should have the chart of polyatomic ions. And so I think we kind of said earlier, like bookmark it, fold the corner, put a sticky note in there, because you'll still be using polyatomics quite a bit throughout second semester. So I might need to look up hydroxide. Its formula is OH, and its charge is -1. But now I still only have 2 ions, a positive and a negative. I still need to make them neutral or crisscross the charges. But either way, if I need more than one of a polyatomic group, I need to put them in parentheses. So this will be Fe and then OH2, 2 groups of hydroxide. All right, let's set this up. So I have 2.50. The unit is moles. The substance is iron 2 hydroxide. I'm going to set up my proportion. The unit that I have is going on the bottom. I want moles to cancel. And the unit that I want goes on top. I want mass in grams. Okay, so I want mass in grams. Mass is found on the periodic table. So I have to do a little sidebar so I can find the molar mass of this compound. Okay, so I'm going to have some iron. Oh, let's see, iron 55.85 grams per mole. I'm just looking it up on my periodic table, leaving maybe 2 decimal spots. In this compound, there is 1 iron. Next, I move to the oxygen. Oxygen's mass is about 16 grams per mole. But now I don't know if we've seen one of these yet. Okay, so iron hydroxide. We kind of talked about what this OH2 meant earlier in the year when we were doing bonding, but now we have to find the mass of this guy. So remember that it means there are 2 groups of hydroxide. We could have written this in kind of a funky way as iron hydroxide. And we could have done something like that, where the iron is +2, -1, -1, everything's neutral. But eventually our ionic formulas look a little weird. And so if we have more than one of a polyatomic group, we just group them together and put the subscript on the outside. But it means that you have 2 of everything on the inside, which I can kind of see if I write it out in a different way. And so when I see that 2 on the outside of the parentheses, you can like distribute that to everything on the inside. So this is really going to be a total of 2 oxygen. 1, 2. Or if I do the same thing with the hydrogen, is molar mass is about 1.01 grams per mole. But I'm going to have 2 moles. 1, 2. All right, I would distribute that 2 to everything on the inside of the parentheses. Now I'm going to add them all up. There we go. Molar mass is really something that eventually you'll be so good at that you probably won't need to even write it out. That you'll just be able to look at a compound and plug the numbers right in your calculator. So I've got my 55.85 plus my 2 oxygen and 2 hydrogen. Awesome. So I got my molar mass. I'm looking at about 89.87 grams for 1 mole. That's the definition of molar mass. When you use the numbers on the periodic table, grams per mole, it's like grams per 1 mole. Awesome. We're good to go. I got moles on the top, moles on the bottom. Those will cancel, and I just multiply across the top. 2.5 times 89.87. And now, they've mentioned this term a little bit in the book called significant figures. It really just refers to how to round your final answer after you do a calculation. And so you just look at the initial number that you are given. So the initial number has 1, 2, 3 digits. And so then you just round your final answer to 3. Oh, that's kind of nice. So I'm going to round this off then to about 225 grams of iron hydroxide. Awesome. And I can see if that answer seems reasonable. Yeah, so every mole is a little bit less than 100 grams. If it were exactly 100 grams per mole, then 2.5 moles would be like 250 grams. So yeah, this seems reasonable. My answer should be something a little bit less than 250.